The universe is an unfriendly place. Planets with lava oceans circle too close to their stars. Pulsars blaze with deadly gamma rays and X-rays. Black holes consume everything in their path. Temperatures plummet close to absolute zero.
You know, most of the universe is incredibly hostile. It's vacuum, it's freezing cold space, or you're burning hot near a star.
The universe is supremely hostile to biology.
Stars gobbling up other stars, black holes eating up entire star systems, galaxies colliding with other galaxies. That's the norm.
It may seem impossible for life to survive in such hostile environments. But here on Earth, life exists against the odds.
The answer lies in a delicate balance of factors that might be incredibly rare across the universe. Let's start with Earth's position in the galaxy. We're located in a relatively calm region of the Milky Way, far from the chaotic, high-radiation areas near the galactic core. Next, consider Earth's perfect distance from the Sun, right in the Goldilocks zone, where it's not too hot, not too cold, and liquid water can exist.
The habitable zone, or some people call it the Goldilocks region, is a distance away from the star where you're not so close where you're going to burn up and evaporate all of your liquids, and you're not so far away where you're frigid and cold. So it's that special region where it's just right.
The Sun's habitable zone includes 3 different planets, Venus, Earth, and Mars. But Mars has a thin atmosphere and is too cold. Venus has too thick of an atmosphere and is too hot. We're the only planet that happens to be just right.
But it's not just about distance. We have a lot of factors that keep our planet stable. Our moon, for example, stabilizes Earth's tilt.
The moon plays a key role in stabilizing the Earth's axial tilt, which gives rise to the nice, pleasant seasons that we enjoy.
Too large a tilt and seasons become too extreme for life to thrive. Earth's tilt seems to be just right, perhaps even rare.
Without the moon, some believe our planet's tilt would have been unstable. Some years our seasons would be unbearably hot and long. Other years wouldn't have seasons at all.
If you look at our moon and compare it to all of the other moons in our solar system, it's actually quite odd.
It's huge, way bigger than any other moon in the solar system compared to its planet.
Earth's moon is ridiculously gigantic. No other rocky planet in our system has anything like it.
It's a giant moon. It's almost like we're a binary planet, 2 objects orbiting around each other to some degree.
It's true moons aren't rare, but our moon is huge compared to the Earth.
Our planet-sized moon is unique in the solar system. And this battle-scarred giant serves as our guardian angel. Its vast gravity raises the tides that breathe life into the Earth's oceans.
Okay, so Earth is weirdly dynamic and has a weirdly giant moon, but there's more. Our entire planetary system is pretty weird. We've only figured this out as the Kepler mission wrapped up its census of other planetary systems. Our solar system has a huge range of planet properties, from the tiny rocky Mercury to the giant gaseous Jupiter and Saturn. In contrast, the planets of most other systems tend to be all around the same size as each other, and planets as large as Jupiter and Saturn are pretty rare, only around 10% of systems.
And let's not forget Jupiter. This giant planet acts like a cosmic shield, deflecting many asteroids that might otherwise crash into Earth.
Earth's solid iron inner core spins suspended in a molten metal outer core, and this motion generates a powerful magnetic field that protects Earth from dangerous space radiation and solar storms.
Our sun is constantly hurling deadly radiation out towards us. Only our magnetic shield, the magnetosphere, saves us. Without it, the solar wind would blow our atmosphere away, and without an atmosphere, liquid water could not exist on the surface.
In order to have liquid water, not only do you need the right temperature, but you need the right pressure. You know, if there were no atmosphere here right now, even at the same temperature we are today, all of the water would boil off into vapor immediately.
There's an amazing amount of water on the surface of the Earth. The Pacific Ocean has an area of roughly half the surface of the Earth. Millions and millions of cubic miles of water.
Earth's orbit is almost circular. We stay about the same distance from the sun all year round. The temperature here is relatively constant. Without this stability, we would not exist.
And so without the stability of the solar system and the Earth's orbit, there's no life on Earth.
We owe everything to Earth's orbit. We get a gentle ride. In an otherwise violent universe, we've hit the orbital jackpot. Yet chaos is never far away. Even within our solar system, there are extreme and violent orbits where life could never survive. Mercury, the closest rock to the sun and the smallest planet in the solar system. Its orbit stretches into an oval shape. At its furthest point, Mercury is 43 million miles from the sun. But at its closest point, it's just 28 million. This close in, it's hot.
800 degrees Fahrenheit, hotter than a baker's oven. Also, because there's very little atmosphere on Mercury, you'd choke. And because there's no air to speak of, the blood in your body would boil and it would burst your skin. You would literally explode on the surface of Mercury.
But the temperature can also fall to 300 degrees below zero, 3 times colder than the coldest place on Earth.
Many of Earth's life-critical qualities or development steps have not been seen elsewhere, nor do they seem to have happened more than once.
These conditions are incredibly rare. While microbial life might exist elsewhere, the likelihood of complex, intelligent life might be far more uncommon than we think.
All we know is that it happened at least once.
But beyond this one little planet, we don't know whether or not it happened anywhere else.
The hunt for Earth 2.0 has turned up plenty of planets. But for a planet to be like Earth, it has to check a lot of boxes.
If you're really looking for Earth 2.0, then you're going to have to find a planet that's the same mass and size as Earth, orbiting a sun-like star at about the same distance, with a similar atmosphere and a lot of surface water that's in liquid form. Good luck.
Earth's tilt seems to be just right.
We're the only planet that happens to be just right.
Just right.